Hi, I'm Thom Fell from Thom Fell Heating and Plumbing. Close in the name. And I'm a heating engineer in Hertfordshire. And this is a notoriously um, bad area for limescale. We have really, really high concentrations of calcium carbonate. And I was called out to replace a radiator and found I couldn't do it because of this cylinder. Hey,
Hi. Morning,
you
Tom.
got
How are you?
excellent. I'm all right.
Thank you so much for doing this. It's just that having these things for people is so useful. Seeing real engineers doing real things and seeing the problem in reality rather than this static picture, which is frankly all we ever do with scale and so on. So I'm
Absolutely.
quite excited about this. So first of all, show me this beastie. Show me what you've got.
This is our
Oh, blimey, look at that.
cylinder, which instead of doing admin, I cut it open.
Sounds like much more fun.
Look at the thickness of that.
Because we talk about 1 mil being 7 to 10% and adding energy, and I talk about 3 to 6 mil being about average, I reckon, but we don't really know.
The element I pulled out this one.
Yeah, that's awesome.
Right, you can see that. Look at the crystal.
That's absurd, isn't it? Yeah. I'm going to ask you to estimate how thick you think that is in millimeters.
Say 11, 12 millimeters we got there. Can you see that? You know, because when you said that the other day to me,
yeah,
I was like, you're never gonna get more than 3 millimeters. And then I pulled that out. I was like, I've got to show this stuff. I've got to show this stuff. But here's the really bonkers bit. And I cut it out. Look.
Yeah.
Look how much limescale we've got.
That's just
that all came out one cylinder.
And that was all in the bottom?
Well, it must have been about a third full.
Right.
A third full.
Good.
So that's water that's not being heated.
Yes. And getting in the way of other bits at the bottom of the tank as well, other operating devices.
I went to actually change a radiator, which is a pretty simple job. You go and change a radiator. I had to drain down, and it didn't stop draining. It kept running continually. And I also noticed that the overflow on the feed expansion tank had been operating when I arrived there. I was like, well, there's obviously some problem there. And the problem was that the coil inside, let me show you. So this coil inside, which transfers the heat from the central, the same body of water that goes around the central heating system, as I'm sure you know, but that transfers the heat to the water inside the cylinder. It's quite nice to be able to see inside, because usually you're explaining this to people and they can't visualize it, but it goes around that coil. It's the same water that goes around your radiators and transfers its heat. Now, that coil had to be compromised, and basically what was happening was the water from the in the cylinder, from the hot water that you would use in your taps, was basically getting into the central heating system, and vice versa, which is quite dangerous because, like I said, if you put inhibitor in your central heating system, like you're supposed to, then those chemicals are going to be getting into the hot water.
Can you please explain, how was it compromised? How was the central heating water getting into the main body of water?
Through that coil. Now, that's the only place that those two bodies of water can meet in the whole of your system. So that must have been compromised somewhere, and that's because of corrosion, and that's almost certainly because of limescale. And can you see the bluey green color there? I don't know if you can make it out.
Yep.
That is sign of copper corrosion.
Yes.
Yeah.
Yep.
So that limescale. I don't really fully understand the chemistry behind it, but because limescale is an excellent conductor of electricity, apparently some some sort of electrolysis happens which speeds up the corrosion process.
Right.
And
Wow.
like I said, you can put inhibitor in your central heating system,
But not.
which will help to stop limescale and rust and corrosion within the central heating body of water. But you can't add that to the water that sits inside your cylinder.
No.
Um,
That's a shocker, isn't it? The one you've got there is an absolute shocker. Okay, so
yeah, it's the worst. I mean, it was so heavy I could not lift it. And normally we're talking, what, 20, 30 kilos max for a cylinder.
did you have you weighed it?
No, I don't. I don't have scales actually. It's got to be approaching 100.
The sort of weights and being able to show the thickness of that is just extraordinary. Take us back in the cylinder, Tom.
Well, no, it's this. This is what's really, because this is, if you were ever using this is the element in,
Yeah.
and this hasn't corroded because this is I think either alloy or titanium, which is a good uncorrosive material. But if you're trying to heat anything with that, you've got to get through all of this first.
And
it's just
Tom,
not going to work. It's going to cost a fortune.
Whole element covered in that thickness?
Yeah. Basically, I couldn't get this out of the hole in the top of the cylinder, this hole where it goes in. So that's supposed to go into that hole. And it was so thick that I couldn't get it out without breaking. I was trying to get it out without breaking it because I thought it's such a stunning thing. But I couldn't get it through this hole that it's designed to come out of. It was so much of it.
So though that entire element, then, can you just confirm to me that entire element was covered as with the elements, with the bits that we see now, but more?
Absolutely, yeah. So yeah, it came round the bottom there, and you covered the whole thing. You can see. I mean, it's just where you can see the cross sections, can't you? A lot of it falls off. It's quite powdery, this stuff in there. So what have we got? We're looking at about 10 mil on there. You can see where that's actually covered the coil. And that's, again, that is not going to be transferring its heat efficiently at all. You know.
Can you tell us what temperature, Tom, you're expecting that to be at, that coil?
Yeah, we're going to be going in at roughly 70, 80.
What?
80 degrees centigrade, sorry. So we're going in and then it will be attempting to transfer its heat. And it's not going to do it very effectively. Now, you can't really slow that down because that's controlled by the pump speed.
Mm-hmm.
So what it's going to be doing is just basically going back to the boiler, heating it up again, and turning it round and round and round. It's going to take forever to heat up this cylinder. And
how big is this cylinder, Tom?
So it's just over a metre tall and just under half a metre wide. Which
makes it,
I think it's a 180.
Right. And that's it. Would you say that's a fairly standard cylinder?
Yeah. This is a 3-bed house job.
Okay. So nothing unusual about that, a standard cylinder for an average house?
Oh, absolutely. This is probably the most common size. It's bonkers. It really is. I mean, we've had some heavy ones, but
yeah,
nothing like this. I mean, the area I got it from is really bad. It's a really notorious area. I haven't tested it. Next time I go up, I'm going to do a test on the parts per million.
Yeah.
But usually we're looking at about 350 around here, 350 parts per million.
Okay.
Which is
high. It is high.
Which is high, yeah. And this is a notoriously bad area for limescale. We have really, really high concentrations of calcium carbonate. How much limescale there is there. absolutely bonkers.
That's great. Okay, Tom, can you do me a quick snippet on where you are geographically? Because everyone goes, "Oh, my water's different." So where is it? Yeah, that. But okay. Where in Hertfordshire?
So I'm based in. I'm actually in south east Hertfordshire, near the Essex border, London, just outside the M25. The cylinder in question was a bit further north from here. The water tends to get harder and harder as you get out towards North Hertfordshire and then Bedfordshire and Cambridgeshire and beyond. I mean, it's hard here. It's like 350 parts per million or 400 when I test it. It's a big problem. Keeps us in work. It really does. It really does. And there's also this fad for black taps at the moment. Actually, on that boat, he had black taps and showers and fittings and stuff. Yeah.
Sorry, back to you. Tell me about the boat.
Yes, on the boat.
Yeah.
Actually, there's a nice story about that. It was so I recently plumbed a boat on the River Lee, which is close to here, and it was a brand new boat, and he asked me to fit it out with black fittings and taps and showers, and everything had to be black, and all the plug holes had to be, the waste had to be black. And I said to him, these are going to scale up really badly, and they're going to be, particularly with the water around here, because he has a filtration system, but it's not going to get out the limescale and the water, and that's just for drinking. And so I said, why don't you fit one of these filters? It's a King of the Road filter. Oh, is that what it's called? Yes, I think so. Yeah. The Halcyan, yes, King of the Road, Halcyan. I installed it, and then he said to me a few days later, Tom, when are you going to come and install this filter? And I said, I've done it. And he said, where is it? And I said, it's right there. And he said, but you were only there for half an hour. And I said, I know. And he said, but where is it? It's just that little thing there. And he said, and that's doing all of the limescale reduction now. It was good. He seems really happy. We've had no problems with the black fitting, so it's great. It's great.
Long may that last. That's great to hear.
Well, at least 30 years.
Yes. At least 30 years, if not the rest. Let's see if the boat lasts that long.
Probably lasts longer than the boat, yeah. I want to highlight how expensive this cylinder change was.
Oh, okay.
So here's the cylinder that I pulled out from this house. It had a compromised coil, which was caused because of corrosion, because of all of this limescale. And this was all brought about from just changing a radiator, and then I discovered that that the coil in this cylinder was compromised, and was because of limescale. Now, I was asked to change just the radiator, ended up having to change this entire cylinder. Now, this cylinder was the best part of £300. And then you've got all of the fittings and sundries and stuff, and you've got a drain down, and then you've got an inhibitor that has to be added to the system and everything. And you're looking at around about 600 quid in order to change this cylinder over. 600 quid that they weren't expecting to pay, which, as you know, is not that dissimilar from the price of a Halcyon, is it?
Tom, does that include parts and labour, or is that just parts?
That's parts and labour. But, a couple hundred quid more.
Yeah.
And all that been avoided. I mean, you can't completely eliminate wear and tear and corrosion within a system. But
so it's not an issue in the larger pipe sizes and the central heating system because there isn't enough limescale to deposit. But in that smaller system, then that's particularly...
It all adds up, doesn't it?
Yeah. No, yeah.
It all adds up.
For different people. So what happens is our customers come to us and they'll have this specific problem. And they'll want us to be able to understand that bit of the problem. Oh, but we've got microbore. Okay, well, then let's unpick that bit. The fact that they're not looking at the whole picture. So we know, you and I know that this thing goes off in a multitude of directions and a multitude of problems. And we know that, for instance, in this house where you've taken the cylinder out, I'm guessing that if you took out some of the pipe work, it would look pretty narrow. The main work, you know?
Yeah.
But that customer is not interested in that problem right now. The only time
it is a big problem. It's constant. It's constant. We're fighting it all the time.
And what I find curious in the UK is that we take a really sort of haphazard approach to it. We don't really take it, oh, it's limescale. We'll just stick one of these things on and we'll cross our fingers. And it's like, okay, we can do better than that. And, you know, if 70% of the UK has this problem, surely we should be trying to do a bit better than that. You know, this is just, it's madness.
Yeah, well, with this cylinder here, I have told them, that they should fit a Halcyon, and they said they've just had a baby, and they've just had to pay out all this money on a new cylinder, and they said next year they're going to fit one. So,
well, tell them that we do 24-month interest-free finance. So we brought it out in September because with the heating issues, the energy prices going up, we've been trying to get finance for a while for our customers. We finally got it. And we said, well, look, we'll pay the interest because it's not huge. We'll pay the interest. They can't have any other discounts or anything like that. We'll pay the interest payments so that someone's still only paying the cost of the unit, but they can spread it over 24 months. Well, that works out at something like 32 quid a month. But they're saving more in energy costs on an average home. You know, your average figures are all a bit, you know, on my average, I don't know if you're average, but, you know, average home saves what, 48 quid a month in energy potentially. So I'm like, well, if you buy it over 24 months, you're actually saving more money with your payments than you're actually spending. So it's worth mentioning to people that we've now finally got finance, so they can start, they can get it installed and they can start saving. We can start clearing out their systems as fast as possible.
Exactly, particularly with something like this where they've just got a brand new cylinder, and we know
it's going to be
bad that,
a year's time. We're going to be playing catch up in a year's time. They'll already have 3 mil on there. You know, it'll pay for itself in under a year. That's a lovely one, actually, because that's got the copper as well as the limescale.
Yeah. That verdigris.
Yeah, look at that. It's kind of pretty in its own way.
Oh, it's beautiful stuff. It's metal, isn't it? I mean, it's a metal.
It's a mineral, yeah.
Yeah,
mineral. But Tom, that's awesome, sir. Absolutely awesome. All right, I shall speak to you again soon.
Yeah, it's nice to talk to you.
And you. Nice to see
you. All right.
Okay, have a great day.
You too. Bye.